Object-Oriented Programming, OOP, Part 2. What we're going to do now is continue along in our discussion about object-oriented programming, specifically focusing in on objects and classes and methods of those classes. We're going to talk a little bit more about constructors. Constructors are special methods used to instantiate objects, and I want to go into constructor overloading and utilizing the quote-unquote this keyword. Then what I want to do is show you some neat ways of achieving polymorphism. As a matter of fact, both of these mechanisms will help us achieve polymorphism, which is many forms, utilizing something called method overloading. So we're going to be talking a lot about methods for a while and special kinds of methods. Then I'm going to introduce you into a relationship that you can have with your classes and your objects called inheritance. And then a topic that comes up in inheritance is method overriding. So let's go ahead and start talking about constructors. To begin, let's examine a class that I previously wrote called employee.java. Now I wrote this a little while ago, and what I did was I created a class called employee, and in there I created an integer called empid, a string strname, and a string department. And I also provided a single method for right now just called do work. It doesn't return anything, so it's a void do work, and it simply calls system.out.println, and it spits out I sleep all night and I work all day to the command prompt. Let's go ahead and compile that just to make sure we're on the right track, to make sure that compiles. And we get compiled. Tool completed successfully. Okay, let's go to the use employees. Now, what I want to do is I want to go ahead and instantiate an instance of my employee. So in order to do that, I specify the data type, because Java is a strongly typed programming language. Employee, emp RB for Robert Barr, is a new employee. Okay, let's focus in on what's going on here in a little bit more detail than we previously did. This is object instantiation. I am instantiating a new instance of the employee class that's going to reference an object in memory called emp.rb. And the way I use that is I do two things. Well, actually, I do several things. I create a variable of the appropriate type, and I call the new operator, and I say next to it the name of the constructor. Now, a constructor is a special method used for object instantiation that always has the same name as the class it is used to instantiate. Now, if you do not write your own constructor, which you clearly, if I go back to the employee.java class, you clearly do not see a constructor in there, what happens is the Java compiler automatically puts a constructor in for you when you compile that does not take any arguments to it. That's why there's nothing in between the parentheses here. This is commonly referred to as the default constructor. So if I go ahead and compile this, the reason why it compiles successfully, even though I did not put in an employee my own constructor, is because the Java virtual machine will go ahead and put the constructor in for me. Okay, so let me show you kind of something that I've already kind of completed here. Here you can see it's the same class, useEmployee.java. And on line number 5 here, I instantiated an instance of the class using the default constructor. So let me put a comment in there, using default. You know, the abbreviation for constructor looks like that, C-TOR for constructor. On lines 6, 7, and 8, I am utilizing fields. Now, the reason why I can access these fields is because the fields are public or default scope or protected. In other words, they're not private. I'll show you here what happens if I make them private, okay? And now here, I'm simply utilizing them, okay? So I'm going to print out several methods. So let's go ahead and compile this, and we'll go ahead and run it. All right, and let's go ahead and run it. Okay, and you can see that it prints everything out. Prints everything out. Employee emp.rb.string name right there. ID right there. And department is right there. Really quick, what I want to show you what happens is if I go in there and I make those fields private. Remember, private locks down the class feature, the method, or the attribute field just to within itself. So if I make this private, and private, and I compile this class, because I got to recompile it because I'm making a change to it. Alrighty. And now I go to recompile the class that's utilizing it. Let me do a control 1 here. You'll see we're going to get an error. Wow. We get, looks like 6 errors. Look at string name private, int emp.id private, string name private, and then I'm trying to use them here. So they're all going to be inaccessible. The only place that they're accessible is actually within its own class. Now, if I just delete the word private, what happens is the access modifier then becomes the default level, otherwise known as, might go by package or friendly level. And we're going to talk more about that scope when we start talking a little bit more about packages. So let me recompile this, the main one, because I made that change. And that compiled well. Now let's go ahead and recompile the one that's using those features, and you see we'll compile just fine. And here we go. So now we're good to go. Now we're kind of right back where we started. All right, so that's another little bit of a discussion on access modifiers, but let's return with our focusing about constructors. Now, wouldn't it be nice if every time you created an employee, you could do something prior to having to start working with it? Let's say every time you said new employee, an automatic database connection was made and it's going to start putting this employee into the database. So what I'm going to do is I'm going to get rid of all this junk for right now. Actually, I am going to not get rid of it, but I'm going to hide it from the compiler with a multi-line comment. Okay, so hide that and hide this. That way we can kind of compare and contrast what we'll be doing here shortly. And the first thing I'm going to do is, instead of allowing me to utilize the default constructor that comes with the compiler, I'm going to put my own constructor in there. And when you create a constructor, you don't use public, private, because they need to be accessible, so they're always public. And because it's a constructor, you don't need a return type. The return type is a reference to the class. Okay? Now, constructors always have the same name as the class they are used to instantiate. So it's easy. The class's name employee, the constructor's name is employee. And I can utilize it basically like a regular method. What I can code in here is, let's say, some database calls, and let's simulate that with println a new employee is created. Okay, so go ahead and put that in there. Now watch. Let me compile that, and then we're going to go ahead and rerun it. And what'll be interesting is when I go to utilize this application, notice how I will not have to recompile. Or actually, I take that back. I'm going to have to recompile it because I've commented that code out. So, but what I'll point out is, when you change one class, you don't necessarily have to recompile the other class. That's modularity and encapsulation and code reusability features, which is a major selling point, feature of an object-oriented programming language like Java. All right, here we go. Now let's go back to our employee or useEmployee.java and recompile that and utilize that. So let me do a control 1, recompile that. Cool, and it compiled right good. All right, let's go ahead and run it. Control 2. Check this out. Let's bring this down. It says a new employee is created. Now, where did that come from? I certainly didn't code that up in useEmployee. It came from the fact that whenever an employee is utilized, I put this line in the constructor that I put in myself. So what I did was I overrode, if you will, or overloaded the default constructor with my own constructor. Okay, so that's one way of utilizing constructors. You could go ahead and put the default constructor in there. But another thing you can do is create parameterized constructors. Parameterized constructors allow you to instantiate objects with some initialized data. For example, watch this. I'm going to create my own constructor, employee. Employee. And what I'm doing here, by the way, is polymorphism. This is an example of constructor overloading. Overloading means I have two methods with the same name, but they do different things. So here I'll put in string N for name, string D for department, and int I for ID. Okay? And now watch what I'm going to do. Now I'm going to go ahead and I'm going to assign str name, the value of N, whatever gets passed in there. I'm going to assign the str dept, department, the value of D, whatever we pass in there. And I'm going to assign int emp ID, the value of I, whatever gets passed in there. Then what I'm going to do is I'm going to say system.out.println, print line, and I'm going to say welcome, close quote, str name. All right, let me go ahead and compile that. That compiled great, and let's now go ahead and start utilizing that version of the constructor. So I'm going to say employee emp JD. And I'm going to say new employee. And now what I can do is I can pass to it my information. Here you can see that, remember, it takes a name, a department, and an ID. So I'll put name, department, and ID in the constructor. John Doe. That's the name. The department is, how about ESS for Enterprise Share Services, and the ID is 121198, something I just made up. Now, let me go ahead and compile that, and then we'll run this. Cool, it compiled. All right, let's go ahead and run it. And let me do Control-2, and let's see what we get. Okay, what we get is a couple of things here. The first thing is we get from line number 5, a new employee is created. That's from the default one here, the no argument one. The second line where it says welcome John Doe is coming from here because on line number 6, I create a constructor that takes 3 arguments into it: employee name, department, and ID. And what it will do is that constructor will automatically print out welcome and the name. To continue to show you that I have access to the other variables or properties of that class, I'm going to also print some more information about. So I'm going to do a system.out.println emp ID for John Doe would be emp John Doe dot int emp ID. Okay, so emp JD dot int emp ID is going to be this number here. So what happens is when I instantiate an instance of employee and I pass this information, it comes into this constructor here as I. It gets assigned to int emp ID. That is definitely a mouthful. Okay, let's compile it. And here we go. So let's go ahead and run it. Okay, check it out. Here you can see I have access to, because on line number 7 here, I did a print line of empid colon space empjd dot int empid. And here you can see where that's coming from. Okay, so that's utilizing constructors. Now, one last thing I want to show you how to do is how you can have constructors talk with each other, if you will, using the this keyword. Let's say for some reason I want one constructor to talk to another constructor. Well, the this keyword allows me to do that. So let's clear some of this kind of information out of here. I'm going to go ahead and uh, quarantine that guy, if you will, so to say, by giving him a comment on that line. And then I'm going to come over here. Now, because I've commented out that line, this version of the constructor will never get called. But what I can do is I could put that in there to explicitly call it utilizing the this keyword. And because I have no parameters in there, it goes to the default parameter or the empty one. If I put parameters in there, it will find a constructor whose parameters it matches. And that compiled. Now let's go ahead and compile this one. Now make sure you see I've commented this line out. So I'm not expecting it to call the line that says a new employee is created because that has been commented out. But I am expecting the other constructor to call that line because I've put in the this keyword into it. And then what happens is that constructor gets called first. Then what will happen is my constructor will get called. Okay, let me go ahead and run this and let's see what we get. First of all, there's a lot of green, which means we have a lot of stuff commented out. The only lines really running are 6 and 7 here. On line number 6, I instantiate an instance of my employee utilizing the constructor that takes 3 arguments. Then what happens is I print out, just to kind of show you that I still have access, or I have access rather, to that object's properties, or methods in that case. That's why you see emp ID here. But notice the very first line. The very first line is created. Why is the very first line written there is because I've explicitly gone ahead in this constructor and I've said this. I've explicitly gone ahead in that constructor and said this. I'm going to comment this out and I'm going to recompile it. All right, now what I'm going to do is I'm going to rerun this. Notice I do not have to recompile it. I will simply go ahead and do a Control 2 and rerun it. Notice now it is not saying a new employee was created because I am not explicitly calling utilizing the this keyword in my constructor. Okay, so that was a little bit about constructors, but I want to turn our attention now to method overloading. What I've done is I've cleaned up my classes a little bit, and I'm just showing you that here's my employee class, and in it I've got my do work method. At this point I just have one method. So I'm going to go ahead and compile that class with that one method. Then what we're going to do is we're just going to use that method. Okay, so now that it's compiled, let me go ahead and go into here, and I'm going to create a new employee. So employee emp rb equals a new employee. And all I need to do is say emp rb.doWork, and let's see what happens. So I Control 1 to compile, and I'll do a Control 2 to run it. And here you can see that I sleep all night and I work all day is printed to the monitor, or standard output rather. But don't you think, I mean, you work for a company, you know what's going on. I mean, more people just do that one type of do work. Well, I can do what's called method overloading. And method overloading is where I have one method with the same method name, but it behaves differently. For example, I could have a void do work that takes a string s as an input parameter. And what I can do is that, let me close my curly brace, well, system.out.println I am an overloaded method. And I'll put dash string. Let me close the quote there. I could do another one. Void do work int s. Okay? And I could put basically the same thing in there. Let me copy this, paste it down there. But instead of pasting, saying string, I'll put int. Whoops. I had that all selected when I did that. Let me redo that. All right, and I'll type int here, int. So now, if I pass a string to do work, it will call the string one. If I pass an int to do work, it will call the integer one. So let's compile it and run it. Okay, so now what I'm going to do is I'm going to come back here and I'm going to do an emp rb dot do work, and I'm going to pass a string to it, so some string. I'm going to do emp rb dot do work, and I will pass an integer 1 2 3 9 8 7. Okay, so let's compile that and let's go ahead and run it, and we should see several versions of the doString method show up. And here we go. The first line is from the empty method, the one that doesn't take any parameters. The second one here is because I'm passing a string, and the third one here is because I'm passing an int. Notice I'm calling the same method. This can become handy. This is polymorphism in action. Basically, what determines what gets called is on the fly, or Java dynamically figures out which method to call based on the method's signature. And the method's signature is basically the list of input parameter data types. That's why I purposely named this an S, because you see a string and an int are different. Now if I made this an int, then this would be an int s and this would be an int s, and that would be the same. I would get a compilation error. It would not compile. Conversely, if I made this a string and I made this, or I left that alone, it would still not compile. So this doesn't matter. I could call, this would generate an error. If I change this to an integer, whoops, let me change that to an integer. Okay, so now I have two methods that take the same number of parameters and the same data type. Well, Java goes, I don't know which one it is. Even if I change the letter names here or the variable names, Java will still not know which one it is. So if I change this S to D, Java still won't know what to do. Now this will work perfectly. String S. Okay, now the signature is different. Something else that's important to understand is that the return type is not a part of this discussion in terms of the signature. In other words, if I had void here and int here, or string here and void here, you know what? That's not part of the signature. Neither is the method's access modifier. So if I had one public and one private, that's not part of the signature either. Now what I would like to do is talk to you a little bit about inheritance. Inheritance allows me to create two classes that relate to each other. Think about it. You have employees in a company and managers in a company. Are not all managers also employees? Do not managers have an employee ID, a name, and a department? Do managers not do work or take breaks? Sure they do. But take a look at my manager class. Isn't that a little bit different than what you might expect? Because notice how in my manager class, I did not recode any of the employee information. None at all. Why? Because I am going to create a relationship between the manager class and the employee class. And that relationship class is an is-a or an is-a relationship. In other words, a manager is a or is an employee. And being an employee, it has access to all of the attributes and methods found in the employee class. So what I do is I reserve my manager class to only write in methods that are unique to managers, like only a manager can hire and only a manager can get bonus. And what I do to initiate this is I use the keyword after the class here, class identifier is I say extends employee. That's it. Now I'm going to go ahead and compile this. Now it's important you understand one rule about inheritance. A class can only inherit from one other class. Java does not support multiple inheritance. You can only have one parent class. Now, a parent class could have several child classes, okay? But you can only have one parent. Kind of makes sense if you think about it in biology, okay? Java kind of mirrors the real world that way. Okay, so here we've gone ahead and compiled it successfully. Now what I'm going to do is jump over to my employee.java and let's create a manager. So let's get rid of all this junk and I'm going to say manager mgr1 is a new manager. Okay, and I'm going to take advantage of the default constructor that's put in there for me. And mgr1 dot, oh, what are one of the methods in there that I put? Let's take a look. How about we use get bonus? So let's come back here and I'll say mgr1 dot get bonus. All right, I'm going to compile that and run it. Now that I've compiled, let's go back to the use employee class here and let's give it a shot. So control 2. Okay, and we can see only managers can get MIP bonuses. MIP stands for Management Incentive Plan. Okay, and only managers are on the Management Incentive Plan at the company. Maybe that wasn't too much of a shock to you because after all, I did define the get bonus inside of manager 1. But let me do this. Let's do mgr1 dot, let me just remind myself what that method name was. Is it take break? Take break. So manager, let's go back to the use employee one rather. Manager one dot take break, and let's call a method from the employee class. So take break, and now let me compile that and run it. Cool. We get a compilation. All right, let me go ahead and run it. Let's do a tools, and we'll come down to and select run Java application. And here we have it. You can see that only managers get an MIP bonus. That comes from mgr1.getBonus. And mgr1 take break, that comes from the employee class. Because you have to remember something. A manager is an employee. Now what I'd like to do is talk a little bit about method overriding. I think it's fair to say that employees do work. Okay, let's go back and an employee does work. And this employee might sleep all night and work all day. I also think it's fair to say that managers do work as well. But I think it's fair to say that managers do work a little bit differently than employees. Maybe managers just manage all day. So let's do a system.out.println I sleep at night and manage all day. Okay. Now this is going to get a little bit interesting. Let's compile that. And now what I'm going to do is I'm going to go to the use employee and I'm going to do mgr1.do work. Okay, so I'll compile and run that. Okay, so now let's do a control 2. Let's see what we get here. Check this out. Here you can see I sleep at night and manage all day. And the reason why I sleep all night and manage all day is because in inheritance, a method is overridden, which means the child method always overrides the parent method. Okay? And overriding means same signature, just that the child overrides it. Now, I could lock down that method by making, let me go in, if I want to prevent method overriding, I could come into this void do work and I can make it final. which means that nobody can override it. So let me compile that, and then what I'm going to do is I'm going to rerun my application. So let me go back to my useEmployee.java, and let's do an old control 2 on that. Notice how all I had to do was just simply recompile the first one. Because I'm not making any changes to useEmployee.java, I don't have to recompile it. So let's do a control 2. And what I'm expecting to happen is an exception. And this is nasty. This is what you're looking at. It is an exception. And an exception is an error. And we're going to talk a little bit later on about exception handling. But here's the basic gist of the message here. Class manager overrides final, and final methods cannot be overridden. It's kind of like a way you could, if you want to implement security on your own class, cannot override a final method. So that's the first time we've actually utilized the final access modifier. We've used public, we've used private a little bit, kind of showed you some of the distinctions between those. We can also use protected, and protected means that only this class can use it, a class that inherits from it can use it as well, so that would be protected. Now what I want to do is kind of review some key terms that you've been exposed to in the last set of series and just kind of touch base with you and make sure we're kind of on the same track here. Let's start talking about access modifiers. Access modifiers can go on methods they can go on methods and fields or properties. And if you make something public, it basically has the visibility of just visible anywhere and everywhere. Like anywhere your class lives, some other class can see a public method or a public variable, if you will. Private is the opposite. It's basically only within the class itself, so nobody else can see it, just utilized for internal to the class. Now protected is available within the class itself as well as subclasses. Okay, protected is within the class itself, the same package, which is also the same directory, as well as subclasses. Now, if you don't put an access modifier on, it just has what's called package level, or I've called it default, and that means unlimited access within the package, okay, just the package. Feature modifiers that we've talked about are like class. If you make something a class, it's a class. Extends means inheritance, so you can use extends to inherit. Final does two things. Final on a variable locks it down and makes it a constant. Final on a method means it cannot be overridden. So again, it depends where you put final on something. So a final method cannot be overridden. Okay? New is utilized with a constructor to instantiate an instance of a class. And static simply means that a separate instance doesn't need to be instantiated in order to have access to a static member variable, field, or a method. Basically, it makes methods and variables belonging to a class as opposed to a separate instance of the class. In Object-Oriented Programming Part 2, we got a good look at some of the rest of the features utilized in object-oriented programmings like Java. Specifically constructors. That's a big one. Constructors are those special methods that have the same name of the class that they are used in order to instantiate unique instances of an object of a class. That's a lot to say, but it's true. Then I showed you a little bit about method overloading, how you can have multiple methods with the same name but different signature, and how they'll act appropriately depending on which one you call. Those are all examples, by the way, all this is examples of polymorphism and encapsulation. Inheritance, utilizing the extends keywords, allows me to create an is-a relationship between two classes, like a manager is an employee. And then method overriding shows you what happens when you have two classes with the same method name overriding each other. I hope you have found this informative, and I'd like to thank you for viewing.